Generator connection accessories. Neutral grounding cubicles. Introduction. The major components installed in a neutral grounding cubicles for large generators are a neutral grounding transformer and a neutral grounding resistor. In addition, it may incorporate a single-phase isolator, current transformer for the measurement of neutral current for input to the relay, voltage transformer for the measurement of voltage across the secondary resistance for input to the relay. All generators' neutrals have to be grounded through an impedance to limit the line to ground fault current to safe limits. Two systems of grounding are adopted for a generator, mainly dependent upon its size. Low impedance grounding, where a generator neutral is grounded through a resistor, is adopted for small unit sizes. High impedance grounding, where a generator neutral is grounded through a combination of a resistor connected to the secondary of a neutral grounding transformer. Compensated grounding, also known as reactor grounding or resonant grounding, falls under the category of high impedance grounding, where instead of a resistor, a reactor is connected to the secondary of the transformer. A perfectly tuned reactor will effectively suppress the ground arc, and consequently it is also referred to as arc suppression coil. Compensated grounding is more expensive and requires tuning. Neutrals for smaller sized generators can be grounded directly through neutral grounding resistors with the line to ground fault current limited to either the rated current or more commonly 10 amperes for a fault at the generator terminals. Low impedance grounding is recommended for small sized generators. For small diesel generators, it is also a practice to connect the neutrals of several generators running in parallel and ground them through a common resistor. In the equation, Ig shall be substituted for a total ground fault current. It is sufficient to rate the neutral grounding resistor for a short time duration of 10 seconds or 60 seconds. High impedance grounding is recommended for large-sized generators. For large-sized generators, it is the practice to connect its neutral to the neutral grounding transformer loaded with a neutral grounding resistor. When the effective neutral grounding resistance value is high, the generator may experience high transient overvoltage due to switching operations of the breaker or arcing faults to ground. The magnitude of the overvoltage is dependent upon the value of the grounding resistor and the capacitance to ground of the generator connections. The higher the value of the resistance, the greater will be the magnitude of the transient voltage. It can be established that transient overvoltage can be kept low by sizing the resistor to such a value that its losses on a line to ground fault are equal to the envisaged capacitive reactive volt amperes of the generator connections of all three phases. The capacitance to ground per phase will be the summation of the capacitance of the generator winding per phase, the capacitance of the surge capacitor installed in the surge protection voltage transformer cubicle. If a generator breaker has a capacitor on either side of its pole, then both these have to be considered. The cable capacitance, if any, from generator connections to the startup transformer. The capacitance of the isolated phase bus and surge arresters are insignificant and can be neglected. Neutral grounding cubicle. Neutral grounding cubicle houses a neutral grounding resistor in case of low impedance grounding, or a neutral grounding transformer and a neutral grounding resistor in case of high impedance grounding. The primary of the neutral grounding transformer is connected to the generator neutral after star formation, either through a single-phase metal enclosed bus terminating on a flange on top of the cubicle or a cable terminating in a cable end box on the side of the cubicle. The neutral grounding transformer and the resistor are installed in separate compartments with wall-through bushing for connections. Depending upon the project requirements, the neutral grounding cubicle may also contain an isolator, medium voltage current transformer and voltage transformer for input to protection relays. Neutral grounding transformer. The neutral grounding transformers are of dry type. The rated primary voltage of the transformer should be the line to neutral voltage of the generator. However, the maximum operating flux density should be such that it has a voltage factor of approximately 2 to cater to the maximum transient overvoltage of the first cycle during the short circuit. At the rated primary voltage, the operating flux density will be close to 1.0 Tesla. This will ensure that the grounding transformer does not saturate. The neutral grounding transformers are short time rated for 10 minutes. The secondary voltage is rated at 240 volts. This will depend upon the sensitivity of the connected relay. Both the primary terminals of the transformer coil shall be fully insulated. They must be connected through a flexible connector of adequate size. This is to ensure that there is no stress on the terminals of the neutral grounding transformer during assembly, transport, or installation. Neutral grounding resistor for low impedance neutral grounding. A neutral grounding resistor may comprise several banks of resistors connected in series. Individual banks of the resistors is essentially rated for 1.1 kV. For a neutral grounding resistor connected to the neutral of a low voltage generator, it is necessary to mount the bank assembly on a standoff insulator suitable for a rated voltage of 1.1 kV. For a neutral grounding resistor, connected to the neutral of a generator rated for medium voltage, it is necessary not only to mount the resistor bank assembly on a standoff insulator rated for the system voltage, but also to insulate each bank with respect to other with a similar insulator. This is because each of the resistance bank is rated only for 1.1 kV. The body of the bank enclosure shall not be earthed. Neutral grounding resistors for high impedance neutral grounding. The resistance can be mounted one on top of the other without the insulators in between. The entire assembly of the banks has to be mounted on standoff insulators. The body of the resistance bank shall not be earthed. Each bank of the neutral grounding resistor is rated for 1.1 kV. Each bank comprises several punched stainless steel elements connected in series. This is achieved by installing conducting washers and insulating mica washers alternatively. The entire grid assembly is supported on a filament wound FRP tube running over a stainless steel rod. The rods are connected to the end plates with a low-voltage insulator assembly. The pattern of punching defines the resistance of each element. It is preferable to have taps at ±10% and 20% of the total resistance of the assembled bank. Thank you. For a comprehensive understanding of the theory and practices of busbar systems, it is advisable to read the book An Introduction to Busbar Systems, where contents are organized in a sequence for ease of reading and facilitates cross-reference. Please procure a copy of the book with a requisition to Bala at busbarsystems.net.